Hey everyone, this is John Oden with Boson Software, and this is Demo Lab 3 NetSim Configuration. In Demo Lab 2, we saw that we could use the tools that are provided with Boson NetSim to create our own network topologies. In this video, Demo Lab 3, we're going to see how to go in and configure the devices in the topology. Let's begin by looking over in the lab tree and loading the lab. This is Lab 3 NetSim Configuration Demo Lab. So to load it into the simulator, let's give it a double click. And now that it's loaded, let's organize our screen a little bit. Notice that the lab tree, we can put it away, we can expand it and view the labs. Now that we've got the lab loaded, we really don't need it, so we can put it back away over here. And also, as we've seen in previous demo videos, let's take the lab documentation and pop it out into an external window. And I've moved it over to my other display, and you could do the same thing, just so that we have a little bit more room for NetSim. And now I'm going to click on the NetMap tab so that we can look at the topology. This topology should look familiar because this is the same topology that we built in Demo Lab 2, and we begin Demo Lab 3 with the topology already built, and we're going to be configuring the devices in the topology. In this lab, we're going to have 4 tasks. The first task is going to be to configure the LAN interfaces on the routers and the PCs in our topology. The second thing that we're going to do is we're going to set up the wide area network interfaces, and then also we're going to need to configure a dynamic routing protocol, and that's going to be EIGRP in this lab. And then finally, we're going to verify our network connectivity to make sure that we've got everything configured properly. Let me direct your attention to page 2 of the lab documentation, and you'll find a couple of very useful tables here that show all of the devices, the interfaces and sub-interfaces, the IP addresses and the subnet masks, and for frame relay, the DELC values that we're going to be using. So you want to keep that table handy, as we'll be referring to it to get the IP addresses to put on the interfaces and some other information as we go along. You can see here at the bottom that I've already got a console window open for the core router, but we need to open additional console windows for router 2 and router 3. So to do that, we can just go up into the topology on the NetMap tab and right-click on the device that we're interested in this case router 2, and choose Configure in Simulator. When we do that, we get a second tab down here for the console window for router 2. And let's do the same thing for router 3. And there's router 3 right there. So we're going to right click and choose Configure Simulator on router 3 and also router 4. So after doing that, we've got 4 tabs down here, and we can easily switch from the console window of any one device to any other. Tap the enter key and I'll see the command prompt respond for each of the devices. Now we've got easy access to all 4 of these devices to do our configuration. You'll notice very quickly that the prompt is the same for all of these devices. Cisco devices, the prompt is derived from the device's host name. So the first thing that we should do is to set up host names in the configuration for each of these devices so that we can tell which one is which when we're going through the console window. So let's go ahead and do that. Before we can do any configurations, we need to go into privileged exec mode, and I'm going to use the enable command to do that. You can see that the prompt changes when I do. Now I'm going to enter configuration mode, and I'm going to apply the host name of core. And notice when I do that, the prompt immediately changes. Let's do the same thing for router 2, 3, and 4. So with that done, and with the host name set for all 4 of my devices, notice that as we look at the command prompts, we can easily identify which device is which. We can also identify by looking at the tabs down here, but we need to do so by assigning a proper host name to each of these devices as well, and we've done that. Continuing along in task 1, the next thing that we're going to do is to put IP addresses on the LAN interfaces of each router, and we're going to enable the interfaces. So let's go ahead and do that, beginning with the core router. We're going to go to interface fast Ethernet 00. Notice we're in config mode here. We need to get into interface configuration mode, and we'll do that using the interface fast Ethernet 00 command. We're going to apply an IP address and a subnet mask. and we're going to use the no shutdown command to enable the interface. And we'll repeat that process for router 2, router 3, and router 4. Now we have the LAN interface on each of our 4 routers configured. Now we need to configure our PCs, PC1, PC2, PC3, and PC4, and we need to apply an IP address and a default gateway for each of those. And each PC is going to use its respective router as its default gateway. In other words, PC2 will use router 2 for its default gateway, PC3 will use router 3, and so on. Let me show you another way. I could scroll around and find the PCs and right-click and choose Configure in Simulator. You saw I did that before with the routers. But let me show you that you can also use this pull-down list here and can choose the devices that you want to configure that way. So if I want to get a console window open for PC1, I can just make that choice. PC2, PC3, and PC4. Now I've got 4 additional console windows that will give me access to the command prompt for each of the PCs. Now the command that we're going to use to apply IP addresses to these PC workstations is not a real Windows command. This is a little bit unique to Boson NetSim, and the reason is that traditionally to apply an IP address to a Windows-based PC, you would use the GUI, you would right-click on the network adapter and a dialog box would open up. So rather than recreate all that in NetSim, we've actually created a couple of commands that are unique to the simulated PCs in Boson NetSim, and these are just options on the ipconfig command. So we're going to do ipconfig /IP. Now that /IP is not a legitimate option on a real Windows-based computer, but it is in our simulated computers here in NetSim. So we're going to do ipconfig /IP. We're on PC1 here, and the IP address is going to be 192.168.10.2 with a mask of 255.255.255.0. Now we're going to need to set up a default gateway. Remember, this is PC1, and it's going to point to the core router as its default gateway. We can see it's in the topology right here. So to do that, we're going to use the ipconfig command again with the /DG option, which again is unique to NetSim. You don't do it this way on a real Windows computer. And the default gateway is going to be the LAN interface of router 1, which is at IP address 192.168.10.1. Okay, so we need to repeat that process for the remaining 3 PCs. And now we have IP addresses and default gateways configured on all 4 of our PC workstations. Since we have configured the router interfaces that point toward the local area network for the core router, router 2, router 3, and router 4, and we have just finished configuring IP addresses and default gateways for all 4 PCs, so we should have connectivity between each PC and its default gateway. So let's go check that and just make sure. So from PC1, I've just configured its default gateway of 192.168.10.1, so we should make sure that we can ping 192.168.10.1. And we can. We've got 4 successful replies, 5 successful replies, so let's check that for the other PCs as well. We're good there. And there. And let's check this one out. And we've verified that we've got connectivity between each PC workstation and its respective default gateway. So the local area network configuration for the interfaces on the routers as well as the PCs has been done, and that completes task 1. Let's move on to task 2, which is going to be to configure the wide area network interfaces on the routers. I've brought the lab document back over just for a moment to review what it is that we're getting ready to do. We've got a couple of different considerations for the wide area network connectivity in our topology. We've got a frame relay cloud here, and the core router, router 2, and router 3 are going to participate in this frame relay connection. And we've got a point-to-point serial connection between router 3 and router 4. So let's go ahead and get that set up. Before we actually do the frame relay configuration, I've done a whiteboard just so that we can talk about what it is that we're getting ready to do. We have here the three devices that are going to be connected via this frame relay cloud. That's core, router 2, and router 3. And I've got a blue cloud in the middle here representing the physical connections from the serial interface of each of these three routers into the frame relay switch, which is represented by this cloud here in NetSim. In addition to the physical connectivity, frame relay has the concept of a logical connection from one device to the other. And in frame relay terminology, we call these virtual circuits. And in this case, they're going to be permanent virtual circuits, or PVCs. PVCs are identified using a DELC. DELC stands for Data Link Connection Identifier, and you can see that I've written them on the diagram here. These DELC values are locally significant to the device, and they don't have to be the same on both ends of the PVC. For example, core sees this connection over to router 2 as DELC 102, but router 2 sees its connection back to core as DELC 201. The same thing between router 2 and router 3. Router 2 sees its connection to router 3 as DELC 203. Router 3 sees its connection back to router 2 as DELC 302. And finally, for router 3, it sees its connection to core as DELC 301, and core sees its connection back to router 3 on DELC 103. In a real-world scenario, your frame relay service provider would assign you the DELCs, and you would configure them on your devices. But in a lab scenario like this, we're free to select our own DELC values, which we've done here. So the DELC values that we configure on the interfaces for each of our devices must match the DELC values that are set up in the frame relay switch in the simulator. Let's hop back to NetSim just for a moment and take a look, and we can find our cloud, which is the simulated frame relay switch, and we can right click on it and choose properties, and we can see those values. If we look at the core router, we can see that its PVC to router 2 is 102, and if we look at router 2, its PVC back to the core is 201, and so on, and all of that matches up with the whiteboard. And you might want to look at this whiteboard and make some notes on your own lab diagram, just so that you'll understand when you're configuring these DELC values in the interfaces what they really mean. When we begin to configure these sub-interfaces on the routers on core, we're going to configure a couple of sub-interfaces on serial 00. The first sub-interface will be serial 00.2, which has an IP address of 20.1.1.1. We're going to configure it to use DELC 102. And then if we look over on router 2, it's going to have a sub-interface on serial 00, which will be serial 00.1, and it's going to have an IP address of 20.1.1.2 on DELC 201. So that represents this PVC right here from core to router 2. Core sees it as 102, router 2 sees it as 201, and notice that both of these sub-interfaces are in the same subnet. When we get into the configuration, you'll see that we're using a subnet mask of 255.255.255.252, which is a /30, and that's exactly what we need for a point-to-point PVC like this. Since this is a /30, we only have two hosts, and that's all we need. So our network is 20.1.1.0. Our first host is 20.1.1.1. Our second host is 20.1.1.2. Our broadcast is 20.1.1.3. And our next network is 20.1.1.4, which is the subnet used by this other sub-interface over here on core. And the first host in 20.1.1.4 is 20.1.1.5. That's the IP address of the first host that we assign to this sub-interface on core. And the other end of that PVC is going to be down here on router 3, where we use 20.1.1.6, and these two IP addresses are in the same subnet because they're logically connected by this PVC. And then we've got the same thing happening between router 3 and router 2 in the 20.1.1.12 subnet, which has a first host of 20.1.1.13 and a second host of 20.1.1.14, and those are the two IP addresses that we're using on this logical connection, the PVC between router 2 and router 3. You'll learn a lot more about frame relay in standalone labs 38, 39, and 40, but I wanted to give you a little bit of a background so what we're getting ready to do in the next task will make a little more sense. So now let's get into task 2 now that we've learned a little bit about frame relay and how our PVCs are going to be set up. So we'll start with core, and we'll go into interface configuration for serial 00. And since this interface is going to use frame relay, we're going to need to set the interface encapsulation to frame relay, and we'll activate the interface by using the no shutdown command. We'll see the interface go up, but then it'll come right back down again because there's no interface at the other end of the connection that's running frame relay yet. So let's set up our first sub interface, serial 00.2. And this is going to be a point-to-point PVC, not a multi-point, so we need to put that keyword on there. And let's apply the IP address. That's 20.1.1.1, and it's going to have a /30 mask, which in decimal is 255.252. And since the data link connection identifier, or the DELC, for this end of the PVC from the perspective of core is DELC 102, we need to use the frame relay interface DELC command to set that configuration. Our second PVC on core is going to be serial 00.3. It's also a point-to-point. And its IP address is going to be in the next subnet, which is 20.1.1.5 is the IP address. This is the 20.114 subnet. And this end of this PVC is identified with DELC 103. So this is what we just finished setting up. Subinterface 00.2 with this IP address on DELC 102, which from the perspective of the core router is its way to get to router 2. And this other subinterface down here is 00.3 with an IP address of 20.115 on DELC 103. That's how core is going to get to router 3. So since each of these routers in our topology has two PVCs, then each router is going to have two subinterfaces, one for each of the PVCs that it has. Now let's set up the subinterfaces on router 2. First, we need to set serial 00 with frame relay encapsulation and activate it with the no shutdown command. And we'll set up our first subinterface, serial 00.1. It is going to be a point-to-point PVC with an IP address of 20.1.1.2 and a 30-bit mask. And this end of this PVC from the perspective of router 2, which is the one that connects back to core, it's going to be on DELC 201. And now let's set up our second PVC, which from the perspective of router 2 will connect to router 3. It's going to have an IP address of 20.1.1.12, or .13 rather, 20.1.1.12, that's the network. And this is going to be on DELC 203. And now let's go over and take care of the two sub interfaces on router 3. We'll use the interface serial 00 command to configure interface serial 00. And we'll apply frame relay encapsulation. And we'll use the no shutdown command to make the interface active. And then we'll set up our sub interfaces. And that completes our frame relay configuration. Just to review, this is what we've set up. We've set up two sub-interfaces on each router, which provides a logical point-to-point connection from each router to the other two. Moving to step 2 in task 2, now we're going to configure this point-to-point serial link between router 3 and router 4. Whenever we have a point-to-point serial link of this type, the DCE end of the link needs to provide a clock source to the other end. So we need to examine the link between these two devices and figure out which end is the DCE end of the configuration. Now you may already know if you remember when we set that up when we were building the topology, but if we didn't know that, let's see how we would find out. We're going to use the show controllers command on router 3 and router 4 to determine which end is DCE. So on router 3, let's do show controllers. And the information that I'm interested in is right up at the top of the output of that command. So we're going to have to scroll back a little bit. And we can see that router 3 is the DTE end of that link. So let's go to router 4 and do the same thing. If we scroll back a little bit to see what we're interested in, we can see that router 4 is the DCE end of the serial link. So we'll apply a clock rate command on router 4. So let's go to router 3 and set up that end of the serial link, this interface right here. And on router 3, this is serial 0/1. It's going to have an IP address of 10.115. And it is also going to be a point-to-point link. So to manage our IP address space wisely and conserve our use of IP addresses, we'll use a 30-bit mask to give us the two host IPs that we need for this point-to-point connection, and a no shutdown to activate the interface. And notice the interface came up, but it didn't hear anything from the other end. It didn't receive a keep alive from router 4, so it just went right back down again. So the issue is that we have not yet established clocking on router 4, which is the DCE end of the link. So let's go ahead and do that now. We're going to use an IP address of 10.116, which is the second host IP in the 10.114 subnet that we're using here. And here's that clock rate command that we apply on the DCE end of our serial link. And we do a no shutdown and we bring up the link. And if we look back at router 3, we can see a console message on router 3 where router 3 has brought up serial 01 on its side because it's hearing keep alives now from router 4 now that we've used the clock rate command to set up clocking on the DCE end of our link. We've done quite a bit of configuration work so far, and it would be a good thing at this point to stop and do some verification to make sure that everything that we've done up to this point is working correctly. So if we look at step 3 and task 2, we're going to do some pings to make sure that we can connect from router 3 to all of the other WAN interfaces that we have set up. So let me bring the lab documentation back just for a moment here, and you can see the console window that I have active back here is router 3. So we're right here, and we're going to issue pings to the WAN interfaces of core and router 2 as well as router 4. So if we can get successful pings from all three of those, we'll know that we've got all of our WAN connections configured correctly. So our ping to 20.1.1.5 is successful, as is our ping to 20.1.1.13. Those two IP addresses were these WAN interfaces on core and on router 2. So now we're going to ping the other end of the serial link from router 3 going down to router 4. And that one is successful as well. So we have got all of our WAN configurations correct. And from router 3, we have successfully issued a ping and have received replies from the WAN interfaces on router 2, core, and router 4. Now at this point, if we were to go to the console of, let's say, PC1, for example, and maybe we tried to ping PC2 or PC3 or PC4. Right now, even though all of our interfaces are up and running, we have configured, or we have verified that each PC can ping its respective default gateway, and we just verified that all of the WAN interfaces can be reached one from the other. But still, if we tried to do a ping from PC1 to PC3, it would fail. Why is that? Well, right now, if we were to look in the routing table of all of these devices, we would find they only know about the networks to which they are directly connected. So if we were to send a packet from PC1 to core with a destination IP address of PC4 down here, then core is not going to know what to do with it, because the only networks that core knows about are the networks to which it is directly connected. So how are we going to overcome that challenge? Well, we're going to use a dynamic routing protocol. In this lab, it's going to be EIGRP, so that each of these routers can exchange routing table updates with the other routers in the topology, so that each router has full knowledge of the networks that are connected to all of the other routers in the network. So that takes us into task 3, which is the configuration of the EIGRP dynamic routing protocol on all of the routers. So let's begin with core, and we are in sub-interface configuration mode here, so we need to back up into config mode. And here we are going to issue the router command to start an EIGR process with an ASN of 100. 100 is the autonomous system number, and all of the other routers that are going to be running EIGRP in this routing domain are going to need to use the same ASN. So we're going to do router EIGRP on all of the routers, and then after that we're going to use the network command to cause EIGRP to advertise the networks that are directly connected to each of the routers. So we use the network command to advertise the 20.1.1.0 network that is connected to core. And when we use the network command, we specify the prefix length with something called a wildcard mask, which you can think of as almost the exact opposite of a subnet mask. The subnet mask of the /30 that we use on these point-to-point networks is 255.255.255.252, and the wildcard mask is just the inverse of that, which is 0003. And we're also going to advertise the 192.168.10.0 local area network. And since it has a mask of 255.255.255.0 configured on the interfaces, we're going to use a wildcard mask of 000.255. And that's how we set up EIGRP on the core router, by using the router command with the EIGRP and an autonomous system number of 100, and then we advertise the directly connected networks. So we need to repeat that process on the other routers. When we use the network command, that effectively enables EIGRP on the interface in that network. And if there is another router on the other side of that interface that's running EIGRP, we'll see the EIGRP neighborship form, and the console message that we just saw tells us that. And router 3. For router 3, we have 4 network statements, one for each of the 2 frame relay PVCs, one for the local area network connection on router 3, and also one for this point-to-point serial link from router 3 down to router 4. And let's wrap up this task by configuring EIGRP on router 4. We were in interface configuration mode, so I used the exit command to kind of back up a level to get us into configuration mode, where we can use the router EIGRP 100 command to set up an EIGRP process on router 4. Router 4 only has 2 network commands because router 4 is connected only to 2 networks. We've got a point-to-point serial network, that's the 10114, and then we have the LAN network pointed back to the switch and finally to PC4, and that's 192.168.40.0. And for that reason, we only need 2 network statements on router 4. That completes task 3. Let's move on to task 4 and do a final verification of our network connectivity. If we've configured everything correctly up to this point, we should have full connectivity within our network. We should be able to go to the console of any of the PCs and ping any other PC in the network. So we're going to go to PC1 and see if we can get a successful ping reply back from PC2, PC3, and PC4. So here we are on the console of PC1. Let's attempt to ping PC2 at IP address 192.168.20.2, and we can see that that ping is successful. Let's attempt to ping PC3, which is at 192.168.30.2. That ping is successful. And let's finally try to ping PC4, which is at 192.168.40.2. And that ping is successful as well. So that lets us know that we've configured everything correctly. We have established IP addresses on all of the interfaces for the routers and for the PCs, and we have set up some frame relay connectivity, both a frame relay cloud as well as a point-to-point serial connection. And then finally, we set up a dynamic routing protocol, in this case EIGRP, so that each router can exchange information about the networks that it's connected to with all of the other routers in the topology, so that we can have full connectivity throughout the network. Okay, that wraps it up for Demo Lab 3 NetSim configuration. We've seen now how to configure the devices and the custom topology that we set up in Demo Lab 2. Be sure to check us out on the web at boson.com, and we also maintain a presence on Facebook as well as Twitter, so you can check us out there as well. Thank you.